All right, so let's continue with example 4 of the differential equations packet. So I brought marker this time. I want to try using writing utensils that are a little bit easier to see. dy dx is equal to y cosine x over 1 plus y squared. So I'm already trying to cheat and look at the notes and see like, okay, how am I supposed to do this? And I don't want to do that. I want to go into this blind and really try to figure this out because that's the most beneficial thing I could do for myself. So I'm going to follow the general rule of like, okay, I want to integrate this. Oh wait, is there an initial condition? Y of 0 is equal to 1. Okay. So why am I putting parentheses there? Y of 0 is equal to 1. Okay, so I need that fact. Otherwise, we won't be able to get rid of the plus c at the end. So first thing I'll do is I will try to get the variables separated. So I'll multiply both sides by dx. So that'll give me a dx over here. But I've got the y and the 1 plus y squared. Remember, you can think about this like y over 1 plus y squared times cosine x dx. And so if I want to get this over to that side, I'll have to divide both sides by y over 1 plus y squared, which an easier way to do that is to multiply by the reciprocal, the 1 plus y squared over y. So let's see, 1 plus y squared over y. We're getting a little bit of what, purple pen, red pen situation going on here. So marker, purple marker, red marker. Okay, so if we do that, then these guys are going to cancel on this side, and over here we're going to have a 1 plus y squared over y dy is equal to cosine x dx, and we're going to be integrating both sides of this. So when we do that, okay, cool, we've got our dy, we've got our dx. So the right-hand side, let's start with the right-hand side because that's going to be easier. The integral of cosine is just sine plus c. Remember, because the derivative of sine is cosine. When we take this derivative, no negative pops out, so we don't need to put a negative on it to have it cancel. This one, you might look at this and go, oh goodness, this is a big mess. In some ways, yes, in some ways, no. Because remember that when it's two things added together, we can actually just break this up and say it's 1 over y plus y squared over y dy. And that makes that integral actually super easy comparatively, because our 1 over y is something we know how to do, and our y squared over y, that's going to cancel and just make a single y. And that's actually very easy to integrate as well. Ignore that sound. Nothing fell on the floor. Tons of paper fell on the floor. Ignore it. Okay, so let's see. When we integrate this left-hand side, we're going to get the natural log of the absolute value of y plus y squared over 2. Remember, we could have a plus c over here, but again, we don't need to write it because there's a plus c over on the right-hand side. All right, and initially we look at this and we go, wow, this is just awful. But let's find out what c is first. So so let's see. We know that y of 0 is equal to 1. So when x is 0, y is 1. And so I'm going to go over here, and everywhere that I see a y, I'm going to put a 1. So that's the natural log of 1 plus 1 squared over 2. I think because 1 and y start with the same w sound, that my brain was like, what? Oh, you're writing y again. No, brain. All right, so now we want sine, and we see an x, so I'm going to put a 0 there, plus c. This is actually really, really nice. Natural log of 1, if you remember from previous videos, is 0, because e to the 0 turns into 1. So we get 0 plus 1 squared over 2. That's a half. Sine of 0 is 0, and so we're just left with c, and so c is equal to a half. And so we can write our final equation, not our final form of the equation, but so we can say the absolute plus y squared over 2 is equal to sine of x plus 1/2. All right. Now, my goal is to solve this for y. And this right here tells me I'm probably not going to be able to. The fact, like, the only way to get the y out of the ln is to e it. But if we e it, if we were to e both sides, which I don't know if I said in a previous video, e-ing things, that is not an actual word. When we say e it or e that, John, what we're really, it's called exponentiation. We're going to exponentiate both sides, but whatever. We're going to e it. The problem is this is going to turn into e to the natural log of the absolute value of y times e to the y squared over 2, and this is going to turn into e sine x plus a half. Yeah, over here we could say y e to the y squared over 2, but like we're going to have to keep on going back and forth from ln's and e's and there's not really going to be a way to separate this. This is where I'm thinking right now. I'm going to go double check my packet and make sure that I didn't forget an important detail, but as long as I didn't forget an important detail, that's where we're going to end. So sometimes we can't get y by itself algebraically, and that's okay. Oh, that's so dumb. All right, so I guess if you want, you could put all the x's and y's on one side and set it equal to the number, but whatever. It's not really important. At this point, it's like, okay, I got this. Now, if it's a multiple choice question, let me go and find the answer that matches this. If it's a free response question, this is fine. So, yeah. So there. All right, let's look at our next example. Our next example, all right. Oh, hey. This one's looking a little bit like physics. Let's check out the physics. All right. So, let's see. We know a of t is equal, use the same color, whatever. I'm writing in red now for some reason. T squared plus 2t. We know v of t is equal to, nope, we don't. We know v of 3 is equal to 20. And we know s of negative 1 is equal to negative 21 over 12. I'm assuming that's good for us, because otherwise, what? Because 21 over 12, that simplifies. They're both divisible by 3. I'm assuming this is going to help us out somehow. All right. You know what happens when we assume? A lot of times we're right. So, like, oh, then, okay, find s of t. All right, we want to find s of t. Well, remember, push vegetables away. It goes position, take the derivative of that, you get velocity. Take the derivative of velocity, you get acceleration. So we push vegetables away. I don't get it, but you guys come up with it. Okay, so let's check it out. You guys isn't a few of you. So I know acceleration. So if I were to integrate acceleration, well then, sure, why not, right? Integrate that, we get velocity. And then integrate this, we get t cubed over 3 plus t squared plus c. And then we know that v of 3, so when t is equal to 3, v of t is equal to 20. So I can go in here and I can write a 20 here. I can write a 3 here and a 3 here. And so that's gonna, sorry, I keep on touching my screen because a stupid error message pops up. It's like, hey, we're having a hard time finding the internet here, or a cell signal. Yeah, because I'm in a basement. All right. There's no lead in our walls. Let's see, we got 20 is equal to 27 over 3 plus 9 plus c. 27 over 3 is 9 again, so that's 18 plus c. So then we'll subtract the 18 from both sides. We get 2 is equal to c. So our velocity equation, v is equal to t cubed over 3 plus g squared plus 2. All right, so now we're going to have to integrate again. Oops, use a different color. Show that we're changing. Integrate. Integrate. And when we integrate, we're going to get position. All right, and then here we'll get t to the 4th over 4, but there's already an over 3. So it's going to be over 4 times 3, which is over 12, plus t to the 3rd over 3, plus 2t plus c. Okay, this is not readily showing me that why we're writing it like this. Oh, wait, that's over here. That's over here. Okay. So, remember that negative 1 is t. So, negative 1 to the 4th over 12 plus negative 1 to the 3rd over 3 plus 2 times negative 1 plus c. Wow. Just the height of professionalism here on the edge of this paper. All right. Oh yeah. There we go. So I'm gonna simplify that side. Oh, and on the left-hand side we get our negative 21/12. I feel the need to say for my friend Jim that is in fact a Rush album, 2112, and I don't care, but he would. So let's see. Well, this is over 12. We could well, if these two things were over 12, then we'd be able to figure it out pretty easily. So I'll subtract this. I'll get negative 22/12. And then the negative 1/3 is, I gotta multiply that by 4 over 4. So that's gonna be negative 4/12. I gotta multiply that by 12 over 12, so that's plus 24 over 12. So this is 20/12 here, negative 22/12. And so when we subtract the 20/12, we get negative 42 over 12 is equal to c. Okay. No, I don't know why we started out with that unsimplified fraction. Okay, so if I simplify this, I can divide them both by 6, because 6 times 7 is 42. So I get 2, and I get negative 7. All right, so final answer, I get s of t is equal to, need a little bit more space here. S of t is equal to t to the 4th over 12 plus t to the 3rd over 3 plus 2t minus 7/2. Cool. Super easy? No, that's ugly. But whatever. That's how we would handle the problem. Okay. So I like to double check. Cool, I did it wrong. But it looks like I did it wrong in my solving. So this is where we go back and we think about what you've done. Let's see. So let me just kind of simplify this out and try the work in the packet. Because maybe the packet's wrong, maybe it's not me. So here we get 1/12 minus 1. No, I wrote a third. Minus 2. Oh. Yeah. So this is what I get for scribbling things really small earlier. I messed up my sign. So that's going to be a minus 24/12 here. It's going to be minus 20. So then that's minus 28/12. So when we add, when we add the 28/12, that's going to be 6 over 12, hey, which is a half. And so our final answer for this is basically what I wrote, except plus 1/2. Okay. So I'm glad this happened. This is the sort of thing that we should be doing when we read math textbooks, when we do other things. If we're really trying to learn, we want to go through the example as best we can on our own and then check with the written material and go, okay, where do we match up? Where do we have issues? Is it me? Is it you? In this case, it was me. Sometimes it's you. I mean, the book. Like sometimes it's not, sometimes you're not wrong. And I do really appreciate those of you that come to me and you go, Canfield, I got this and you got this. I think you made a mistake. Like, we need to be able to have that boldness to question, so-called authority and say, well, I got this and you got this, and I'm pretty sure I'm right. And those of you that do this on a regular basis, you do it in a really humble way that's not saying you're wrong. You're wrong and you should feel bad for being wrong. All right. Okay, here we go. Our next one. I feel like something is missing somewhere. Nope. Okay, cool. So here's a slightly more complex differential equation. Let me copy it down. X dy dx minus 3yx cubed is equal to 0. Okay, so this is a not so separated differential equation. So first things first, I'm going to get dy dx by itself and then try to separate stuff. So I'll add the 3yx cubed to both sides. And then I'm going to divide both sides by x. Now, doing that, dividing both sides by x, there's a side note here that I want to mention. There's an algebraic side note. By dividing both sides by x, we are saying x can never be 0. Because if x is 0, this breaks. Dividing both sides by x here, we're dividing both sides by 0. We have just broken everything. So x, you can't be 0. Now, that doesn't seem to matter in this initial condition here, but occasionally that comes up and that's a problem. And so we need to pay attention. Hey, am I introducing domain problems as I go through this? And no, we're not for this individual question, but 0. Okay, so dy dx is equal to 3yx cubed. So now I can do just a traditional separation of variables. So dy, and I am uncomfortable right now. I'm like, this doesn't feel right. I wonder if I'm messing something up. I need to see this through to its logical conclusion, and then I'm going to go back and check. And if I have to redo the whole problem, I have to redo the whole problem. I want to learn, and so I'm going to do everything that I can do that I think is true, and then I'm going to check in, and I'm going to go, okay, is this fair? So multiply both sides by the dx, and let's be real here. I would do this in one step. I don't like doing this in 2 steps. I divide both sides by the y or the 3y. It depends on how you want to handle it. I'm going to divide both sides just by y and get 1 over y dy is equal to 3x cubed dx. So when I integrate both sides here, I get the natural log of the absolute value of y is equal to 3x to the 4th over 4 plus c. And then we know that y of 1 is equal to 1. So that means that the natural log of the absolute value of 1, which is just the absolute value, is 0. Bam, right? Okay. Over here, we get 3/4 plus c. Because you plug 1 in and you get 1 times 3. So subtract the 3/4 from both sides, we get c is equal to negative 3/4. So before I continue, I am going to I'm glad that I double checked, because when I divided both sides by x and I talked for half an hour about it, I made a dumb mistake. So we got our x squared, we got our x squared, we got our x squared. Now this is x cubed, that's a 3. Okay. So like I said, Yeah, my ideas were fine. I made a silly mistake, so I'm going to pick back up at the integral of 1 over y dy is equal to the integral of 3x squared dx. All right, so I get the natural log of the absolute value of y is equal to x cubed, not over 3, just done, plus c. So now I can plug in the 1, 1, and we get 0 is equal to 1 plus c, so c is equal to -1. That's really nice. Let's see, did they get a different plus c than me? Yeah, they got a different plus c than me, but you'll notice they divided both sides by the 3 because they wanted to deal with fractions and be unhappy. I wanted to deal with not fractions and be happy. So now I get the natural log of the absolute value of y is equal to x cubed minus 1, which if you look at theirs is different than what they got. However, this is what I got. Just I didn't have to do all this stuff with the 3. So if I want to get y by itself, I will have to exponentiate. I'll have to e both sides, and I'll get y is equal to, okay, hold on, put the absolute values back in. The absolute value of y is equal to e to the x cubed minus 1. And the reason I'm going to drop the absolute value is because I know that e to any power, pick a number ever, will never be a negative number. So I don't need to worry about it being positive or negative. And then, we always know that whatever we're going to get is positive, and so it's positive. Okay, so I got that. That is the solution to my differential equation. It matches the packet. All right. Sorry, I just had to trigger my motion sensor to be like, yeah, no, there's still somebody in here. He's just not moving a whole lot. All right, so let's keep going. I just read the title. It says we're going to do a second order differential equation. We've already done a second order differential equation. That physics problem was a second order. Let's see, d2y over dx squared is equal to 4x plus 3. And we know y prime of 0 is equal to 4. And we know that y of 0 is equal to -2. Okay, let's see. Hey, there's no y's over here. So when I separate my variables, I got my dx squared over here. We're going to integrate that. On the left-hand side, we get y dy. And on the right-hand side, we're going to get 2x squared plus 3x plus c dx, right? So this is the way that I'm leaving this notation is a little bit funky. We could just write, we could just over here, we just call this y prime, like divide both sides by the d, and just be like, okay, is it y prime? No, it's just dx. Okay, overthinking things. Okay, so yeah, me trying to be fancy wound up making it a little bit weirder. Okay, so y prime is equal to 2x squared plus 3x plus c, which I would imagine a majority of you wouldn't bother trying to separate the variables and stuff like that. You would just go, okay, we know how to integrate. We know y prime is 0 equals 4, so 4 is equal to zeros. Oh, that 0 goes away, 0 goes away. We just have c is 4. So we know that y prime is equal to 2x squared plus 3x plus 4. So I was getting myself caught up in this weird little notationary issue over here. I didn't need to. So then when we integrate again, we get y is equal to 2x cubed over 3 plus 3x squared over 2 plus 4x plus c. We know y of 0 is -2. Oh, that's fantastic, because plugging in 0 just goes away, goes away, goes away. and then c is going to be -2, because goes away, goes away, goes away. And so we could say y is equal to 2x cubed over 3 plus 3x squared over 2 plus 4x minus 2. Double check my answer. Hooray. No silly mistakes this time. Oh yeah, that's not true. Silly mistakes up here. All right. But as we learn and as we think through things, we make mistakes. That's okay. It happens. All right. Oh, hey. Oh. Oh, cool. The first 8 problems from the homework are, hey, don't do this. All right, I'm going to make a whole new video for the homework. I will go through the entire homework assignment from start to it's over, and yeah. So, cool. Hope this was helpful. If it wasn't, that's fine. Yeah, bye.